Welcome to Wilfong-Captures. My name is Tommy. Today we are doing a thermodynamics heat expansion experiment to show the expansion of heat and properties of water when it gets heated and air as it gets heated and how that affects the pressure and the volume. So to do this we need a bottle, a balloon, a pot of water, and a stove. Let's get started. So we have the bottle. We put a little bit of water in there just because it will help conduct the heat a little bit better, and it should work a little bit faster and better because the water will then turn into a vapor and it will expand more than just the air by itself. And so you can see the balloon slowly rising. Zoom in a little bit here. And it's slowly starting to rise. As the water and the air inside are starting to expand, it displaces the air and makes the balloon bigger because of the pressure that's building up inside. So now we have brought the glass from the boiling water outside into the snow and cold, very cold table that we have outside. And we're going to put the snow around the bottle as much as we can, getting as much surface area of the snow to make contact with the glass. That will help improve the speed and the change because there will be more surface area for that heat transfer, as well as there will be more snow, for say, than just setting it on the table, and that will change the speed that it gets sucked in. And so you can see that it's slowly crumpling up. You can actually see it. My father's helping me a little bit with this because he was like, hey, why don't you put it outside? So I was like, yeah, that would be cool. And he was interested in seeing it. So you can see the balloon starting to shrivel up, and it's shriveled up more than when we first put it on. Well, I first put it on, and then it's like sucking itself into the actual bottle. It did need some assistance since this was quite a tight balloon to the bottle, and so we just pulled it a little bit and it kept sucking itself in. And so the reason why it's actually sucking in is because now the pressure on the inside of this bottle is less than the atmospheric pressure on the outside. And so the atmosphere is pushing in on the top of that bottle and on that balloon. And it's causing then the balloon to go in. And the the contents, you can see how it goes in just then after we moved it a little bit. And so the contents are still getting condensed down because it's getting colder and colder and it's condensing, and that's causing the volume of the contents to become smaller, but yet the mass is still the same no matter what, because mass does not change. And so you can see how it's getting sucked down. And so by it's getting sucked down, now there's the atmosphere on the where that hole is on top of the bottle. That atmosphere can get in there and it's pushing on that other side of the balloon into the bottle. causing the volume of the atmosphere on the inside, but then the volume of the actual air that's in the bottle, for say, is changing, but the mass is still the same. So then we just waited a bit. We were putting some more snow on, and so we have about 2 ounces of water in there in a 12-ounce bottle, and then we have about 10 ounces of air, and that shrunk down by about, came down into the bottle about 2 inches deep. So, and then when we were holding it, it warmed up a bit, so that's why it's sticking back out a little bit. Then, yeah, we're just trying to get it to. We were hoping that it would suck in a lot more, but it just wasn't cold enough. It was only like, it was 26.6 degrees out, so it wasn't super cold. But the base temperature at this, it was at 72, and now it's getting close to 26.6. It wasn't fully at 26.6 because it wasn't that long, but whatever. And when it was boiling, it was at 180 degrees. So, and that's what it looks like after we release it into the cold. Well, that is my experiment for thermodynamics, the heat expansion of the air inside of a bottle with 2 different heats. I hope you liked the video. I'll be hopefully doing some more. This was for engineering thermodynamics class. And thanks again.
Tell me pretty lies, look me in the face. Tell me that you love me, even if it's fake.